Okay, well, welcome everyone. It's my pleasure to introduce Julia Stoyanovich, who's visiting us from the Department of Computer Science and Engineering at the Tandon School of Engineering at New York University. And it's actually appropriate that this is MLK Day because Julia's research and teaching focuses on the ethics of data science with a particular focus on data management and on equity and equality in results. And I think that many people have become aware of the need for ethical standards in data science, and Julia is really on the front lines of developing these standards. She's leading these efforts with her research. For example, she has an NSF Big Data grant called Foundations of Responsible Data Management, which includes people here at Michigan, Wisconsin, and University of Massachusetts. And through the Data Responsibly Consortium, which Julia established, this project is producing analyses and tools for operationalizing fairness, diversity, transparency, and data protection. Her public service includes membership on the New York City Automated Decision Systems Task Force, to which she was appointed by Mayor de Blasio. Last year, I heard Julia's plenary session at the Research Data Alliance in Philadelphia, and I was very impressed with her ability to explain the subtle ways in which algorithms can produce unfair results. So when I got back here from RDA, I immediately wrote to JAG and said, we have to invite this person to speak at Midas. So I am very pleased that you'll all benefit from hearing her too. So please join me in welcoming Julia Stoyanovich.
Thank you for the wonderful and very humbling introduction, George. So we have a lot of time together, and I think that I will just speak leisurely, and I will ask you to please ask me questions as I present this, because there's no way that I will get through all of my slides in any case. And I already know what I'm going to say, but I don't know what you all can ask. So please just raise your hand and interrupt, and we can discuss and pause at any of the topics that I've prepared today. So I will speak about an aspect of responsible data science, and in particular responsible data management. And I will place this work in the context of an ongoing attempt at regulation that George referred to already, namely at New York City Local Law 49 of 2018 that pertains to automated decision systems used by New York City agencies. So this all sounds a little bit cryptic. Why do we care? Well, Europe has the GDPR. We in the US don't have a federal level regulation that guarantees anything like the GDPR does in Europe, in the EU, at the federal level. And so what we're starting to do in the US is act at the level of cities and states to start figuring out how to do regulation in this very, very complex space where data and algorithms are used in ways that impact the lives of individuals, of population groups, and of society at large. And New York City prides itself on being the first municipality in the US to have attempted to do regulation in this space. So this law, Local Law 49 of 2018, was a law that was passed by New York City City Hall that essentially compels the city to start thinking about these issues. So what I'm showing you now is the original draft of this bill that fits entirely on this slide. This bill was proposed in August 2017, and I'm highlighting the occurrences of the word data because I'm a data person and I thought it was interesting. But in a nutshell, you're not supposed to read this, but what this says is that whenever any part of New York City government, a New York City agency, government agency, uses an algorithm in any way that is impactful, they should make sure that the code of that algorithm is posted publicly online. And that's the extent of the law. Do you think this is a good idea? let's post all code that anybody in any agency uses online. So it's a good idea to some extent. Why might it be problematic? So I personally am skeptical, and not because I'm against, of course I'm for open sourcing code, but the law is very vague, and so actually something like Microsoft Word would also be in scope here. So why don't we post the source code for Microsoft Word? So operationally this is difficult, but another issue is that in my view, it's neither strictly speaking necessary, nor is it sufficient to put the code of a process online to actually get at the spirit of what this law is trying to do, and that is transparency, explainability, accountability. So why is it insufficient to post code online? We've all written code, yeah.
It assumes that everyone knows how to read the code.
It assumes that everyone knows how to read the code, A, right? And that's not a correct assumption to make. And suppose that you know how to read the code. Would that actually go all the way for you in terms of transparency and interpretability? I'm asking, right? So therefore, I think that the answer is no. And that is because data, right? I mean, in part, because we don't know what data this code runs on. We don't know specifically what effects it has on the data set. If it's a machine learning algorithm, we need to know what data it was trained on. Just telling me what the architecture is of the neural network, for example, is not going to really help me very much in terms of understanding how the system is affecting my life and the lives of others. So, long story short, a law was adopted using some input from members of the public. And this was actually a time, I don't think I'm including this, where I decided that I should be a concerned citizen, and I went to City Hall and I testified at a hearing. This was a terrifying experience. I've never testified at a hearing before. Just telling them what I think, that this is a good idea in principle, but really we need to think through a little bit more what we mean here and how we might get to an outcome that gives us transparency and accountability. And then the law was adopted, and to many, it was disappointing because it did not actually trigger any immediate action on the part of New York City agencies. It didn't tell agencies to post the code online, to post the data online, to describe their methodology. Instead, it said, let's create a task force. And this task force will sit together and think for 18 months. And at the end of the 18 months period, it will come up with a report. And in this report, there will be recommendations that will help New York City agencies figure out how to respond to requests for an explanation from individuals about how a decision was reached that affects them. For example, I'm a parent and I want to ask the Department of Education, why was my son given a seat in this school but not in this other one? This is something that I should be able to ask the Department of Education and get an answer that I can understand. So that's the first point. This is my summary that relates to the law directly. The second point is that city agencies need to have means to interrogate, both internally and also publicly, their ADS, automated decision systems, is what they call them, ADS, algorithms and data and the whole thing together, for bias and discrimination against members of legally protected groups. And the third point is that New York City agencies need ways to allow members of the public to assess how these ADS function and are used, and there need to also be ways to archive them together with the data they're used for the purpose of public oversight. So the task force was appointed with great pomp, saying that this is going to be a groundbreaking thing, that New York City is leading the way. I was fortunate to have been appointed to this task force. I'm not sure exactly how that happened, probably because I showed up to testify, but it's still a mystery to me. But I'm very happy actually for having had that experience. The road was very bumpy. So the 18 months of the task force's meetings where the task force was made up essentially of two kinds of people. New York City agency representatives who knew a lot about how the city works, but not very much about algorithmic transparency. And a bunch of us external members who didn't know how New York City functions. We didn't have access to any of the data or of the ADS more generally that the city uses. And we felt like we need to know the details, the specifics about these systems to come up with specific recommendations other than, oh, don't be evil and please respect people's privacy, right? And for that, you don't need a task force, really. So unfortunately, there wasn't really that trust established for some reason. Well, I understand the reasons a little bit better now. But while the task force was meeting, at least initially, there was very little information that was flowing towards us from the city. We spoke to the task force leadership through the press. So this is one of the articles in which I'm quoted as saying that we need concrete examples. And after that sort of an adversarial interaction, things actually started to move. So public pressure does work for governments. I mean, this is one lesson that I learned here. So after this article and a few others were published, we were in fact given examples from various agencies, from the Department of Transportation, the Department of Education, even the New York Police Department, surprisingly. The examples weren't very, very detailed, but it was more than nothing. So I think that that was a small victory, actually. And then the report finally came together. It really is a document that shows consensus that is a fairly high-level consensus among this very heterogeneous group of individuals with very different expectations, different incentives. But it certainly, I wouldn't consider it a failure. I think that it was a solid step in the right direction in establishing trust between the city and external members of the public, essentially, right? That's who we are. And the recommendations were published by the mayor in November. The report was published. And on the same day, the mayor issued an executive order establishing an algorithms management and policy officer. And this is actually the first such office in the country again. And this particular office is going to be responsible for picking up where the task force left off, for really coming up with concrete recommendations that are specific to every agency about explanations, about showing that there is no discrimination, and making information publicly available. So again, I think this is a positive outcome. What's very important is that we were able to agree on 3 high-level principles as part of the work of the task force. And these are summarized here. So the first principle is that we should not be using algorithms, data, AI, just because we have them. We should only be using them where we can show that they promote innovation and efficiency in service delivery. So just because you have a risk assessment tool and someone sold it to you and you paid a lot of money for it, doesn't mean that you should be using it, right? This is funny, but it's also really, really sad because this is, this is what's going on, and I'll get back to this later. So this was very important for us to have that where in the sentence, and it took an entire meeting to get this. Just kind of to give you, a sense of how the dynamics work with these efforts. Promoting fairness, equity, accountability, and transparency in the use of ADS. Yes, we all agreed on that. Now the question was at what level, sort of, we agreed. And reducing potential harm across the lifespan of ADS. So this is also very, very important. We need to make sure that we think about the potential benefits, yes, but also the potential harms of these automated decision systems, not after they are deployed, but when we're first conceiving of them. Do we need them? How do we collect the data? Where do we store the data? How does the entire process of procurement or development and of deployment impact New York City and its population? So this is very important, and I'll return to this point, across the lifespan. So my perspective, actually, I'd like to summarize here, is part of the press release that accompanied the release of the executive order and of the task force report. Among the recommendations that we made, I think there were 27 or 29, something like 12 have to do with getting the public more closely engaged in the process of ADS oversight and educating members of the public as well as members of the government, as well as data scientists who are employed in government, on the issues of ethics and responsibility, of the harms and the benefits that these systems bring. And to me, again, this is another point that is very important, is that we were able, among the recommendations, to pay so much attention to the education and public engagement angle. And I'm hoping that New York City, in fact, will start investing in these efforts that are recommended in the public education and public engagement efforts, so that we're able to move beyond the harmful extremes of techno-optimism and techno-bashing and into a thoughtful and productive conversation about the role of technology in society. Because right now where we are is either that computers are magical and great or throw out the calculator, right? But the truth is somewhere in between. Computers cannot do everything, no. And no, we should not be throwing out the calculator. Technology, in fact, can be very helpful to us. So let's try to figure out how we can negotiate the spectrum here, rather than flipping kind of between these polar opposites. So this was a bit of a lengthy introduction, but I'm happy to discuss this because I feel like this was a unique experience in my own career so far, and I will continue to stay engaged with this effort. And I'd love to share this experience with you. You know, being a computer scientist and a member of the public, and not at all somebody who's been part of any government in the past. So let me know if you'd like to discuss this for a few minutes, and then we'll move on to the more technical pieces. Any questions? We can, yeah, please.
Could you say more about how you convince people that just because they have an algorithm doesn't?
So how does one convince people that just because you have an algorithm, you shouldn't be using it? You need to explain to people what algorithms are and how they work, right? That there is an actual objective, for example, in a machine learning setup, there is something that you're learning and that you're validating against the ground truth. So if you cannot express your objective mathematically and precisely, an algorithm is not an appropriate way to encode what you have in mind. So it's hard. We really do need to, so just think about your parents, your grandparents, right? What would it take for you to explain data science, algorithms to them, and do it. Try and do it. Try to explain. You'd be surprised. You understand this yourself really, really well. Therefore, you should be able to explain to your grandmother. So try to do this, and let's try to do this more and more, because it really is our responsibility. People, it's not their fault that they don't understand. We need to explain to them. Okay, so we can come back to this when we discuss also at the end. So what are these ADS? What are these automated decision systems? I'll give you an example just to illustrate some of the points. And this is a somewhat hypothetical example. So suppose that you have a system, and we do have such systems today, that uses data and algorithms to assist homeless individuals and families, to suggest particular interventions for them to receive and pathways through the system, so sequences of interventions that would have as their ultimate goal placing that individual or a family into a stable housing situation. So here I'm showing two of the pathways that are possible. And what we want these systems to do is to allocate interventions, services, and support mechanisms to recommend pathways through the system. And then we also want to be able to evaluate the effectiveness of individual interventions, of specific pathways, and of the system overall. We want to evaluate its effectiveness in terms of whether it is helpful to individuals and families being served, and we also want to make sure that we are doing resource allocation efficiently, that there aren't beds and shelters that remain vacant, for example, when there is demand for them. So in this example, the requirements that we have are to be transparent and accountable to members of the public, both to the individuals being served and also to taxpayers, to the public at large. We want to achieve equitable resource distribution so that it's not the case that some of the more desirable, access to the more desirable services and interventions is only available to particular demographic groups, for example. And we want to be in the process to be cognizant of the rights and preferences of individuals and respectful of their rights and preferences of the individuals that we are helping with these interventions. So these are some dimensions of responsible data science, and I will speak about some of the research very, very briefly, just highlighting some of the work that my colleagues and students and I have been doing along each one of these dimensions. But before that, you know, how do we model responsible data science? We are data scientists, computer scientists. Here we have to model, right? So what is our model here? Very, very simply, we have a data set. It's beautiful and nice and clean and rectangular. You should be sensing some skepticism already. And then this data set is being fed through this magic model that learns something from it, and then it produces recommendations. So here I'm showing these recommendations in the form of a multi-class classifier where a color corresponds, for example, to a particular service that a homeless family receives. So the FATML, Fairness, Accountability, and Transparency in Machine Learning community, has been looking at how we can make this portion, input, box, output, fair, accountable, and transparent. So, and they've been doing a lot of work. And I'm actually, in a way, part of that community, so I'm somewhere here, maybe, in one of these bars. So this is a compulsory picture by Moritz Hart. Please wake up, it's funny. That people started thinking about fairness in machine learning in 2011, and then we're off the chart, right? So we're 2020 now, and of course I cannot continue this line because it would be somewhere up there of the slide. So all of these smart people have been thinking about FAT in machine learning, so are we done? Would be too short a talk, so probably you know that the answer is no, we're not done. So what I want to know is how did this data get there, right? And it's actually important for us to know how the data got there, because if we start intervening, if we start explaining only in the last mile of data analysis, from beautiful data set to insight, we are too late to the game in a sense. So what we need to think about is the entire data science lifecycle, from data sharing and annotation through data acquisition and curation, querying and ranking, and only then to analysis and validation. And this, of course, you know, there's no canonical way to depict the data science lifecycle. This is my particular one, but it's important that it's a life cycle, right? That it's not a straight line, that there are feedbacks here. And so my claim is that responsible data science requires a holistic view of the data lifecycle, and this is some of the work that my colleagues and students and I are doing. So to illustrate some of the questions or types of questions that we may want to answer, suppose that in this beautiful pipeline, data, method, result, you find that women are underrepresented in the favorable outcome groups. And when we talk about algorithmic fairness, we may denote this as group fairness fails or statistical fairness fails. What should we do? Should we fix the model? Of course. But maybe if we knew that the input was generated with this query, give me every row from a table R where status is unsheltered, this is homelessness examples, right? And length in that status is greater than 2 months, then that result, that beautiful data set, only has 10% women. But if we were to change our query slightly and say greater than 1 month, then this would give us an input in which 40% are women. And this would give us a much more effective way to mitigate than just fixing the model. Suppose that young people are recommended pathways of lower effectiveness, that there is a high error rate for this population. We could try to fix the model, of course. But maybe if it were the case that mental health information was not shared for this demographic, for this population, and we knew that this information really gave very valuable signal for us to determine which interventions and pathways are helpful, then we should go back to the data acquisition step and look for additional data sets that would help us gather this information. Finally, suppose that we find that minors are underrepresented in the input altogether, compared to what a caseworker may know to be their actual proportion in the homeless population. What should we do? Should we try to fix the model? It's unlikely to help. So instead, we should realize that minors' data was not shared, probably for fear of violating existing laws. And so what we should do is go back to the data sharing step and help data providers share the data while adhering to laws and upholding the trust of the participants. So these are just some outlines of research directions that I hope that many of you will start working on. What we are doing is working towards a system, kind of broadly construed, like this is not a centralized kind of a database, but rather a system of loosely coupled components that we're calling FIDES that encodes responsibility by design. And this is work that is generously funded by the NSF and where JAG works very closely with me and with a few others. So what we have in mind is to provide systems support for responsible data science through all life cycle stages. encoding responsibility by design rather than as an afterthought. So let me give you a couple of research highlights at this point, just to give you a sense of the kinds of work that we do. So I will start with data protection, and this is very long ago, 5 years ago or so. This was a paper that I co-authored together with a few folks and with a student on collaborative access control. So what was the idea here? Many of us in data management who started working in responsible data science actually have done some work on provenance in the past. And there are very close technical connections seemingly. And we would like to figure out really how provenance, explaining how a data product was derived, right? From what other data and by what sequence of steps, how this can be brought to bear on these questions of interpretability and transparency, but also data protection. So here the idea was that we would give a data owner a method to specify access control, on the base relations, on the raw data that they collect. And then this data would be transformed. It would travel through the system in a sequence of steps where each one of these steps can be expressed by a relational algebra operation or by a data log query, more precisely. And then the system would automatically propagate whatever the data owner specified at the level of the base relations through the system, so that the user doesn't have to bother with both explaining how to compute results at every step and also saying who should now have access to these results. So the example that we're using here is there's a photo album with wedding photos for a couple, and the content of the photo album will be different for their grandparents and for their college friends, because maybe the grandparents don't need to see photos of them drinking heavily at the after party or something, right? So that's the idea. But there are, of course, applications here in any distributed system in which you can express operations in this language, in data law. And we're using fine-grained provenance technique. So another line of work, and this is something that we're continuing more heavily today, has to do with usable differential privacy. So differential privacy is all the rage, right? You probably know that the US Census, the decennial census, will be using differential privacy this year, 2020. So differential privacy is a mathematical framework. Many very, very smart people have been developing methods within this framework, but there are actually very few usable tools that somebody could just download, click a button, upload a data set, and done. You have your data set with noise added, or a synthetic data set, a semi-synthetic data set that you can then go and use. So my research background is not in differential privacy, but my colleagues and I saw a need to build this tool for consumption in the public sector, and so we went ahead and built this tool, the data synthesizer, and it has actually paid off even for us ourselves, because we use it now to generate data sets for our experiments in databases, and I use it in a class that I teach to illustrate differential privacy concepts. So I welcome all of you to use it and to complain when it breaks, and I think it's actually pretty good for how simple it is. So the idea here is that you get an input, a CSV file, from a data owner. The data owner can run this themselves, right? They just download the Python library and they can run it. The tool summarizes the data set, and then it's going to, from that summary, and that summary can be of different kinds, generate a sample. The way that we generate the summary actually encodes differential privacy. So we add noise if the summary is a Bayesian network, for example. We add noise both when we construct the Bayesian network itself and also when we learn the conditional tables at every node. And so then that network, that noisy network, encodes the information that you're preserving about your data, and from there you can draw a sample of any size. And this sample is statistically similar to the original data, to the input, yet it is released under differential privacy guarantees. And then we also give, so this tool was used actually by a public sector participant, at least one, and we are looking now, actively working with other potential users of this tool. So this is what a data owner would see, and this is a kind of a nutritional label, and I will return to this concept in a little bit, of a before and after. This is what my real data set looked like. This is the distribution of the attribute age on your left. And this is in the synthetic data. So you can see that the distributions are similar, but they are not exactly the same. And this, of course, is by design because noise was added. Here you can see a pairwise correlation matrix. Again, on the left is the before in the real data set. On the right is the after. So all of this is very easy for a data owner to generate essentially with one click. So happy to discuss this further. We started taking this idea of privacy-preserving synthetic data generation also in another direction where we want to generate data sets that are both privacy-preserving and bias-correcting. So that if we know that, for example, a particular data set does not have sufficient representation of a demographic group or of a geographic location, we can judiciously augment it with that data when we release. So this is about data protection. There's, of course, remains a lot of work to be done here, and I think you should all start working on 1 or 2 or 3 of these topics. Next, I will say a few words about diversity. And this is work done together with Jag and with my student, Kei Yang. So this is probably going to be the most algorithmic component here. And I didn't ask, what is this class? Are you guys computer science, data science students? What is the level? Are you grad students? Yeah? Okay, so let's see. Let's see if you know any game theory. And so suppose that you have a ranked list of individuals that are of 2 kinds, and these 2 kinds are denoted here by color. So you can think of color as representing gender, for example. And they are ranked by some score that expresses their perceived quality. And your goal, say that you're an admissions officer at the university, is to select 4 applicants from among these to then interview them in person. So how might you do this? You might take the top 4, or you might take candidates in proportion by color to their representation in the input. So I would take 1 blue and 3 red. Or you might take an equal number of blue and red. Which of these is the right way to select applicants? It's a trick question. Huh? Tell me. There isn't the right way, right? It depends on what you want to do. It depends on what your laws tell you. It depends on what your ethics tells you. It depends on your domain. But all of these presumably make sense, right? So you, when you're running the system, you would know which one you want. So what we're doing is we are allowing you to specify constraints on the number of candidates of each color that you would select, and we will help you select candidates of highest quality under those constraints. So specifically here, I'm saying that for each category I have 2 categories here, blue and red. I want to pick K sub I elements, that's a number, that's between some floor and some ceiling for that category. So something like at least 1 and at most 3 candidates of each color would be a set of constraints. And in total, I need to select exactly K candidates. K is 4 in my example here. Make sense? So now let's go back and start building a solution from the following problem. So suppose that my goal is to hire a single candidate with a high score. And the twist here is that candidates arrive 1 by 1, and I need to decide on the spot, once I've interviewed them, whether I should hire them or if I should go on to interview the next candidate. A key is that candidates arrive in random order. The order in which they arrive has nothing to do with their score. They don't arrive better to worse or worse to better, just some random order by score. How do I decide whether to hire a candidate or to move on to the next one? Have you guys seen this problem? What is this called? So this is a beautiful classic problem called the secretary problem. So the secretary problem has been known since at least the 1950s. And it's stated exactly as I told you just now, but a little bit more formally. We want to design an algorithm from picking an element, one element, from a randomly ordered sequence to maximize the probability of picking the element with the highest score, the maximum element. And the solution here is very elegant and is provably the optimal solution in terms of giving you the highest probability of selecting the best candidate of the sequence. So what is this strategy? What is the solution? I have to know how many candidates I'm willing to interview. And that is the number n here. N equals 6 in my example. What I do is I first interview some number of candidates without hiring any of them to get a sense of how good my pool of candidates is. This is known as the warm-up period. The length of the warm-up period is S, that is the number n, how many candidates in total there are, divided by the number E and the floor of that. So in my example, that's 2 candidates. I interview 2, don't hire anybody, and I record the best score that I have seen among these candidates. I call it T, threshold. This score in my example is 4. After this, I will hire the first candidate I encounter whose score is better than T. This is going to give me a solution with a competitive ratio of 1 over E, and that means that it gives me the highest scoring candidate with a probability 1 over E, about a third. And this solution for this particular problem formulation is the optimal solution. We cannot devise a strategy that is any better than this. So this is very nice. There are a couple of proofs in the literature. Some are more elegant than others. But this is just one of these beautiful problems that you kind of learn and you take away with you. So now what do we do with this? Another step on which we build is, and this is also not our work, from 2007, there was an algorithm, a strategy developed for the K-choice secretary problem, where the setup is the same, but now you need to select K candidates. They all are of the same color, still blue. And the solution is very, very similar to the classic secretary. It says the same length of the warm-up period. I interview 2 people still. That doesn't depend on K, it only depends on N. But I record now as many scores as I need 2 candidates to select. So if I want to select K equals 2 candidates, I need to record 2 scores here in my thresholds. And then I will start hiring candidates whose score is better than the current minimum. So the first candidate I hire, the length of the warm-up is 1. Sorry, the end of the warm-up is 1. I will hire 1 candidate whose score is better than 1. That's this candidate with a score of 3. I then get rid of 1 among the thresholds, and the next candidate I hire needs to have a score that's better than 4, and I hire 5. Make sense? Okay, so now what do we do with this? Why am I telling you about the secretary problem, the K-choice secretary? Well, remember how we have also a sequence of these candidates, only they are of 2 colors, red and blue. And so what I want to do is hire K in total, but under these constraints, at least and at most this many from each category. So what I will do is reuse, but in a non-trivial way, the K secretary problem. I will, in my example here, let me illustrate. I have 6 candidates of each color, and I want to select 3 candidates in total, such that at least 1 and at least 2 are from each color. So what will I do? Any ideas on how I will use K-choice? I can fast forward to the less technical after this. Have I lost you all? Okay, let me fast forward now. So what I will do is I will run actually 3 K-choice secretary problems in parallel. And this is important because by running them in parallel, first I'm reusing some information. And secondly, I'm treating candidates from the different colors, from the different groups separately, differently. And this is very, very important. So what will I do here? I will accept in the first stream that I run, floor number of candidates from the red category. I will accept in the second stream that I run, floor number of candidates from the second category, so 1 and 1. But to fill in the third spot in my K, I could take either the blue or the red under these constraints, and I should pick the one that has a higher score to give me a better solution. So that means that I will run 1 stream of these candidates mixed. And this is how that works. So my warm-up for the blue category ends at 1. 6 is the best score. I will accept 8. My warm-up for the red ends at 2. 4 is the best score. I accept this one, 5. And then I also run this mixed stream that looks at the same candidates at which the individual ones look. And here I want to select one more. So my warm-up here ends here, and I accept this candidate with a score of 9. And this gives me this combined solution, the one with the check marks next to the items. And you can see here that this is a pretty good solution in terms of utility. Overall, utility is the sum of scores here of the candidates that I selected, please.
So if we're going to interview and people can quiz, why don't we just wait till the end?
Because the rules of the game are such that you have to either accept a person or interview the next one.
And like, would that be realistic, like in the real world?
Yeah, so this is one of the assumptions that you make. We also have one variant where we actually have a deferred list, a small deferred list. So yes, indeed, once you interview somewhere, you need to make a decision pretty quickly. Think of yourself when you're applying to grad school or to college. Maybe it's not extreme as this. Maybe it's, not one candidate at a time. But if you can have a small deferred list, this does improve things sort of empirically, but asymptotically it's the same result. Yeah?
Maybe I'm jumping a little bit ahead, but what if the ranking is skewed between different groups?
Yes, thank you. So it is particularly important if the scores differ between groups, which would give you different rankings between the groups, right? So if you have the same score distribution that is being used for both groups, in fact, you don't need to do anything extra. You can just run your stream and hope that you will get roughly the candidates in the proportion in which they come in. When we have a score difference, that means in our applications that there's some historical disadvantage perhaps that people have been seeing that we need to correct for. And so here, in fact, I'm showing some experiment. This is the most insightful and an obvious in hindsight kind of an experiment that shows that it is very important to stratify your processing by group if there are score differences. So in my example here, I have two subpopulations, A and B. They are of the same size, and the scores of population A are lower than the scores of the population B. These are synthetic. I'm just sampling from two Gaussians, and the mean is shifted. So if I do what I told you just now, if I run a stream for each category independently, then I'm able to see how good the A candidates are and hire the better candidates compared to that category. And I see how good the Bs are, and I hire the better candidates from that category. So what I'm showing you here is that by incorporating diversity, I'm getting a diverse set of candidates such that in every group, the candidates I pick are best from among that group. So your accuracy is 1 if you got the very best candidates. It's lower if you got slightly worse candidates. So the claim here is that it's important, and this is an affirmative action style intervention that I'm talking about. It's important to be giving an opportunity not just to a random set of individuals who are disadvantaged, but from a disadvantaged group, you want to pick those individuals who have the higher scores, who are trying harder, right? Because you want to make sure that they succeed, if nothing else. You don't want to build bad precedent that then makes it so that people don't perceive that there's worth in studying, for example, right, for these exams. So it's important actually to select the better candidates from each group compared to themselves. But now here, if I run a common stream, I'm going to take from category B the better candidates using the secretary problem guarantees. And from category A, I will end up taking candidates from the end of the stream because I've run through my stream and I've not seen anybody whose score exceeds the threshold because group A drives the threshold. Group B, sorry, drives the threshold. Right, so here, yes, I'm still able to meet my diversity demands, constraints, but for group A, I'm getting candidates that are not the best ones in that group. And this, in a nutshell, is diversity by design in as simple an example as I can give you. And this sort of a X by design really is a thread that I want to pull through this entire line of thinking, right? Fairness by design, diversity of design, transparency by design, not as an afterthought. Not run your process and then in a post-processing step, try to see if you can find some women to fill in the missing spots. Make sense? So yes, in fact, diversity is important. It's been written about in the popular press very eloquently by Kate Crawford, for example. And we also have a survey paper that came out a couple of years ago now that gives a review of diversity methods as they pertain to big data algorithms. Now, a very quick highlight on the work on fairness. And here I will start by giving a bit of a background, because I think that this is actually a sort of an insightful nugget for people, especially who've not thought about this very much before. So there are all of these examples in the popular press that we encounter where, you know, hiring algorithms are gender biased, and risk assessment tools are showing racial bias, and you know, many other scenarios exhibit this phenomenon, that there is bias in the outcomes, that we're not selecting a sufficient number of outcomes from particular demographic groups, and these outcomes are desirable, in fact. So in these situations, again, the picture is that we have a data set, we have a method, and it produces some predictions, or it places items into these outcome groups. So what do we mean when we talk about bias in predictive analytics? These are all predictive analytics. Statisticians, of course, have been talking about bias for a very long time, and also in the machine learning literature, the word bias has been used before. And typically, it means that the model that I'm using does not fit the data well. For example, I'm trying to fit a linear boundary, linear classification boundary, but the true boundary is not linear. It's not a linearly separated data set. When we talk about, for example, racial bias in criminal sentencing, we don't mean statistical bias at all. What we mean is that there is societal bias in the data. So what do we mean now? How can a data set be biased? One interpretation is that my data set, of course, is a picture of the world. And it may be the case that I took a distorted picture, that my data set actually does not represent the world such as it is correctly in some sense. By sending all of my police cars, for example, to a particular neighborhood, I'm only arresting in that neighborhood. And so therefore, I'm going to see an overrepresentation of that demographic and that neighborhood in my data. Or by not ever having hired any women into technology positions, or very few women, I will not see enough of a female representation in my data set of women doing well in technology. So again, this is the world such as it is. I take a picture and the picture is distorted. That's one way to have bias in the data. Another way, however, is suppose even that if you were able to take a perfect image of the world such as it is, the world itself may not be correct. The world may not be how it should or could be. There may be injustice in the world itself. And importantly, 2 points here. A data set is not going to know whether it's biased, and it's not going to know for what reason. It won't know whether it's a distorted image of a perfect world, or it's a perfect image of a distorted world, or if there are distortions at both levels. So that's one. The second point, of course, you see my world is incorrect in these quotes, right? Who is to say what a correct world looks like? Surely not an algorithm. Surely not a data cleaning method, right? It's up to us as individuals and as a society to debate what it is that we could do to make the world a better place. And I'm sure that even in this room, where many of us are like-minded individuals, we are not going to agree, even here, on what that better, more correct world would look like. So these are problems that a data set and an algorithm cannot solve. Humans have to be very significantly in the loop here. So whenever there is a company that tries to sell you software saying that they're fixing bias in hiring, do not believe them and don't pay them money. And likewise for the criminal justice system. Any discussion points on this? Yeah, I'll open it up. Please.
I mean, certainly these are concepts we talked about for a long time.
Right.
In other areas, you might call it talk about maybe validity analysis or external validity.
Sure.
Generalized. Third one is but I think that well, the data set itself obviously doesn't have the way that the data is generated.
Right.
Should tell us. Example, basic premise of how the data is
Right.
And yet, so how do you, the question, really the challenge works is how do you document that? So
Right.
the data gets available, you can actually generate it in a way that's much different.
Yeah, so I agree with you fully, right? So one of the issues here that I'm not talking about here is just the risk of misinterpretation, because I'll repeat, as the data travels and it gets further away from the person that collected it and understands it, the higher the risk of the data being misused. And this risk is becoming greater and greater, right? Because we share these data sets, we repurpose them. I told you just a couple of words about these, privacy preserving, bias correcting data sets. What the hell is that gadget, right? I mean, how do I even know what that is useful for? How do I explain and annotate my data set in such a way as to quantify its fitness for use for a particular task? So that certainly is a very, very important issue that I'm not discussing on this slide. I think that I'll have time to talk about it, but maybe not. We have this work on nutritional labels that Jack's group is also very, very active in, where the idea is exactly that, is to help people repurpose data in principled ways while controlling this risk. Right. So importantly, when bias is in a data set for one reason or another, and that data is about people, then bias can lead to discrimination. And in the kind of a very, very quick summary is that ways in which we quantify fairness and diversity, there are very many. There are very different fairness and diversity notions. There does not exist a single one to rule them all in philosophy or in law or in social science. And computer scientists were for a short while under the impression that we will come up with a definition that will solve this problem, that will have a fairness definition that just works, but that of course is hubris, right? So we of course cannot solve that issue either. There will never exist a single fairness definition to rule them all, and so the answer to the question of what's fair is really how do I make the choices that I'm encoding into my processing transparent, so that people, users, developers, members of the public know what these knobs are and they have some access to them and a way to discuss and debate and turn these knobs in ways that are meaningful. And when we do this, we should be careful to decouple, when we talk about fairness, when we code up these systems, we should be careful to decouple our beliefs about what is or is not fair from the mechanisms that are consistent with those beliefs. And to illustrate this, I will tell you about this court case called Ricci v. Di Stefano from 2009. Have you heard about it? Yeah, so Ricci v. Di Stefano is a case that reached the Supreme Court. It's about firefighters taking a test for promotion in a fire department in Connecticut. And when the results became apparent, it turned out that none of the black firefighters scored sufficiently highly to be promoted. And so the fire department decided to throw out the results of the test and not promote anybody for fear of being accused of disparate impact, meaning of treating a population group that has been seeing a historical disadvantage, again, adversely. And then the white firefighters sued, invoking the legal doctrine of disparate treatment that says that you cannot use someone's race, whether it's white or black, in this case, to make decisions about them. They said, you used our race, white, to disadvantage us. And this case went all the way up to the Supreme Court, and the title says already how it was ruled. It was ruled in favor of the white firefighters, upholding the doctrine of disparate treatment. And it is not because this is the correct or the incorrect version, right? So what I want to say is that there is no correct or incorrect here. It's all people's beliefs and it's all their politics. So to know how these cases will be ruled, you can look at the composition of the Supreme Court. And in that particular case, the majority opinion was authored by Kennedy and the dissent was by Ginsburg. So simply looking at the composition, we could have foreseen how the case will be ruled. So do you know what another case is that's bubbling up to the Supreme Court right now, where we'll be seeing a similar decision most likely? It has to do with universities. actually know the Texas case, but it's diversity in admissions, the Harvard, right? So probably that will be ruled in a similar way as this one if we have a similar set of judges, right? So the reason I'm saying this is not to kind of reaffirm what my politics is. I think it's pretty clear based on the fact that I'm studying these questions, but it's just to say that it's really not about correctness or incorrectness or mathematical definitions. It's about people's innate beliefs. So when we encode these fairness measures, for example, into our algorithms, we have to be very honest and say, I'm doing this not because of math, but because I believe that the data is representative of the world, or that the data is not representative of the world, or of the world is not how it should be. Right. So I talked to you so far more or less about fairness in terms of proportional outcomes, right? We didn't really make this precise because I didn't want to dwell on this in this talk, but there's another interpretation of fairness, and that is error balance. Have you guys seen the ProPublica study, Racial Bias in Criminal Sentencing? So those of you who are students and have not seen it, this is your homework. May I assign homework? Yeah. So this, is folklore at this point. ProPublica did an investigation on the use of a tool called Compass that is used in courts in the United States, in many jurisdictions, to advise judges, to help judges figure out whether to release somebody on bail pending trial. That's one use case, and another is how to sentence them once they're found guilty, how long a sentence to assign to individuals. And this tool produces a score, a number between 1 and 10, a pair of scores really, that quantify how likely somebody is to recidivate, to commit a crime should they be released. So ProPublica journalists analyzed the predictions of this tool in a particular county in Florida, and they also looked at whether or not the people that are in the data set went on to be rearrested 3 years down the road, and used rearrests as a proxy for whether or not they recidivated. So what they found was that the tool was very, very grossly inaccurate, and this is disturbing on its own, but also what they found was that the way that the tool made mistakes depended on someone's race, was not racially neutral. So this is perhaps the most striking result here, that says that of the individuals who were labeled high risk, likely to recidivate, but who were not rearrested and who we suppose did not recidivate, this is the false positive rates of the tool, essentially. Among the white individuals, this was 23.5%, and among the blacks, it's almost 45%. So these are very, very high error rates, and false positive rates for blacks are almost twice as high as they are for whites. False negative rates, predicted to be low risk, yet did recidivate, almost 48% for the whites and 28% for the blacks. So this is a problem. It's a very high stakes domain. The tool is making decisions about the lives and then about the liberty of individuals, essentially, right? And yet it's so inaccurate and so racially biased, as was the claim by ProPublica. So the question is, can we achieve error balance, which is the interpretation of fairness in this domain? Of course, we need to keep error rates low, but at the very least, we need to make sure that if you know someone's race, you cannot use it to predict whether they will be a victim of a false positive error, for example. So fairness as parity in outcomes and fairness as error balance are two ways to view fairness in algorithmic processes. And in our own work, we've done, we've made some modeling and some algorithmic advances in how you incorporate fairness into rankings, ranked outcomes. So what I'm showing you here is the very first paper that we wrote on this in 2016, and this was actually a paper that defined for the first time what it means for a ranking to be fair. And here it's shown pictorially just to say that your gender shouldn't inform you as to your position in a ranked list. So this, in a sense, is parity in outcomes, right, for these protected groups. I'll skip this. And then there's some more work that we did that concerns fairness and parity in outcomes. This was together with Jag and Abol, his former postdoc here, whom many of you might know. But then another recent line of work is actually one where we are looking to combine parity in outcomes that enough people get a desirable outcome with error balance. And this is a paper that recently appeared at HCI. And it's a very, very difficult balancing act. So I'll summarize it just very, very quickly. I don't know if I have more time or not. Yeah. So here, and this will remind you of the secretary problem a little bit, the goal is to pick 4 candidates, including 2 of each gender. So I have genders here, male and female, and at least 1 candidate per ethnicity, white, black, and Asian. So what you will notice here is that this is a more complex setup, right? Because each candidate is both of some gender and of some race. And so it may be difficult for you to satisfy all of these constraints at once, right? How would you do that? And while you satisfy these constraints, you want to make sure that you're maximizing the total score of the selected candidates, right? You want to maximize utility subject to your diversity constraints. This is a meaningful thing to try and attempt. And here, of course, I have an example that is, in a sense, adversarial, where I have all men of each ethnicity with higher scores than the women of that ethnicity. Scores are in parentheses. And that all white candidates have higher scores than the black, higher than Asian. Just to illustrate the point, right? So if I were to satisfy my constraint and to get a set of 4 candidates with the highest score, these would be the candidates I select. And the problem here is that I'm not selecting the best possible candidates from each group. So in particular, I am selecting the best male and the best white candidates. There's nobody higher scoring here for either male or white. But I'm not selecting the best candidates for female because I'm missing C and D. I'm not selecting the best candidates for black and the best candidate for Asian, right? So this is similar in a sense to a loss in error balance. What we're losing here is balance in utility per group. And this is, kind of loosely speaking, due to these intersectional effects, an interaction between categories. It's not just race and it's not just gender that I'm considering, but the intersection of the 2. So an alternative solution is this one that gives me just a slightly lower score, but what it's doing is it's balancing the loss per category. Here, I'm able to now satisfy in-group fairness for female much better because I'm selecting the best female. I'm selecting the best black individual at the cost of not selecting the second best male, right? So I cannot do this perfectly, but things are a little bit more even. Do you get the kind of the gist here of what I'm trying to do? Because really, all of these things, they are about balancing different objectives. What are these objectives here? I have 3. I have utility. I want the highest scores that the data set tells me. I want diversity. I want to have enough items per label as I specified. I'm an admissions officer and these are my criteria. But I also want fairness in this sense, that I want to balance the loss per category. And this is non-trivial to do. So I'm going to skip the rest of this. This is just to give you a sense that we have actual fairness measures here. Yeah. Okay. So let me do this now then. Yeah. All right. So loss in this sense means that I am being unfair towards individuals who belong to a particular category. Like I'm a woman, I'm the best among the women, yet I'm not getting selected. Or I'm a black individual, I'm second best, I'm not getting selected, but actually the person getting selected is the 5th best. So this is unfair to me as a black individual. So here, this is illustrated by this particular measure that we define to capture this loss, and it just is essentially a regret, a per category regret. So these are the female students. This is the highest scoring skipped item, item D. The green ones are the ones that were selected. This is the lowest scoring selected item. D is unhappy to this extent, we're saying. This is one plausible way to define it. The score of K divided by the score of D. And so I can compute this for every category now. Every value of gender and every value of ethnicity in my example. And then what we do is we use an integer linear program to add balancing this score to the set of constraints. And I'm definitely not going to go into details of this, but it's a very cute solution. Please take a look. And it actually does work. So what I'm showing you here is that before we did our thing, there was a lot of a spread in terms of how good the candidates were that we were selecting. So very best candidates here, not so good candidates here. And when we enact our solution, we limit the spread. We make things a little bit worse for the top categories, but a lot better for the bottom ones. So I think I'm out of time, so maybe I will just end on showing you the nutritional label, which is one of my favorite gadgets. And this is a way to annotate data sets with fitness for use information. I'm showing you here rankings just because I like rankings, and it's a nutritional label for rankings that shows how a ranking was computed, that's the recipe, which actual attributes of the items mattered for the ranking, and they can be different than the recipe. I'm showing some diversity information here, stability, and fairness. And I won't be able to go into any detail here, but please take a look at the paper, and we have a system also that's in the open source. What we want from these rankings is that they should be comprehensible. People should understand them. And so for us to make a claim that a label is comprehensible, we need to know who we're talking to. Who is that audience that needs to understand? They need to be consultative, provide actionable info, something that I can do to improve my outcome. Something like don't be black is not actionable. Pay off a credit card is actionable, right? They need to be comparable. So for different data sets, these nutritional labels need to be something that I can look at and say, this data set is better for my task than this other data set. And this implies a kind of a standard. And they need to be concrete, meaning that they should be able to help us determine whether a data set can or cannot be used for a particular task at hand. So if you'd like to know more, please talk to me. There are many, many publications. Well, not so many. There are some publications on the website called dataresponsibly.com that you can follow up on. I will skip another project. This is computational social choice. Also happy to talk about that offline. And I probably am out of time. If I were not, I could tell you about how we teach responsible data science at NYU. 2 minutes, okay. So we do teach responsible data science at NYU. We do it at the Center for Data Science, which is the counterpart of MIDAS. The Center for Data Science is an independent entity within NYU with 16 joint faculty. So I'm one of them. 50% of my salary is paid by the Center for Data Science, and there are many other people here. We offer master's, PhD, and as of this year, a bachelor's degree in data science as well. And right, so that's it. We have really good gender parity. This is a chart for the master's program. So we have more women than men in our class right now. And we recently got a grant from the NSF under the NRT program to build up and scale up our PhD program with the idea that data science is of course about methods, but it's also about translation and responsibility. So I teach a responsible data science course at NYU. So what you heard today is a kind of an intro, really, to some of that course. And it is a requirement of our new BA degree in data science. So all of our students will take responsible data science as a required course. The course is technical. All of the materials are online. There are Jupyter notebooks there. There are slides there, reading. So please help yourself to the materials. Let me know what you think. And it only requires introduction to data science as a prerequisite, not machine learning, which I think is also very important. So when we teach this stuff, it needs to be accessible to people early on in their careers rather than as an afterthought. It's a real course. There are labs, homeworks. There's an exam. If you are an instructor, you can email me and I can send you my questions and solutions. So to wrap up, the punchline is that, yes, data science and data management in particular are algorithmic, and therefore one might be tempted to think that these are not biased. And yet all traditional evils of discrimination actually exhibit themselves in this ecosystem, and they do so at scale and opaquely. Transparency will help us prevent discrimination, and regulation and civic engagement and public education, and not just public, but also education in the higher ed setup are key to making any progress in this area. Responsible data science, I think, is our new frontier. Thank you very much. I'm sorry that I talked so long. I wanted you guys to talk, but yeah. Please, any questions? Yeah.
So one thing you didn't mention, which seemed to have an application to a couple of these things you talked about, is measurement error and score on scores.
Yeah.
That might affect both the optimality of certain algorithms or others, and then also clearly ranking.
Right. So the question is, how does measurement error impact any of this? So one of the lines of work that we have that kind of feeds into the nutritional label is on stability of rankings. And so stability is, how likely is your ranking to reshuffle if your model changes a little or your data changes a little bit. And so we have some initial results there we have a paper actually for what happens when the model changes. And a portion of the tool already incorporates a very simple kind of change in the data measurement error model. So I think that, yes, you're absolutely right. For rankings in particular, it's very, very important. There is not, to the best of my knowledge, a general understanding of this. As far as I know, for rankings, people haven't looked at stability at all. And I'm sure that in other domains, this is also very important. In particular, it's going to be important for cases where you have a particular demographic underrepresented in your data, and so there, any amount of variability might really throw off your results, right? So when we talk about these phenomena, like we do generally, we should make it a habit to measure accuracy not only across the board, but also in subpopulations. It's very important, especially if the distribution is skewed. Yeah. Please.
How do we operationalize these solutions? I'm thinking about how I read articles that will identify algorithms that are biased, sort of problematic with large numbers broadly. And the company in the article will say, oh no, like, you're doing this wrong. We can't tell you how we do this because of trade secrets.
Yeah, that's just nonsense, right?
Yeah,
I mean,
but I also hear that, like, the question then is, like, what do we do at that point?
yeah, so trade secrets is one way that companies say that they cannot disclose to you. And in some cases it's okay, right? I mean, if it's like a recommendation for what shoes to buy, fine. But if it's like whom to incarcerate and for how long, definitely shouldn't be fine. Unfortunately, we don't currently have regulatory mechanisms to compel companies to disclose code. So Compass, its code is still black box. We still don't know what it does. So, participate in, engage, participate in government processes, I think is the answer there. We don't have a good answer to these questions. Again, because of this magical thinking, people think that just computers, if something gives you an answer and the answer is 2.5, it knows what it's talking about. And companies have a very easy time convincing non-technical people, policymakers, HR managers, anybody, right, that what they're selling is real because it says 2.5 and there's a model and somebody has a PhD. So I think regulation and also just explaining to people what's going on, right? Because I don't believe that every developer in every company is evil. People just are not used to thinking in these terms. Many people self-select for computer science because they think they never have to look at a human. They just, look at the computer screen, and we no longer have that luxury. Yeah.
Well, thank you all.
Thanks.